My name is Ajay Chankramath. I'm the CTO and Managing Director for Platforms and Products at Brilio. Brilio is a 10-year-old digital transformation company who has been actually doing a lot of work within the platform engineering space and Gen AI. My topic for today is going to be AI-Augmented platform engineering, which sort of brings together both those ideas. So let's just jump right in. So what we wanted to talk about today was how do you actually apply some of the Gen AI principles to improve the platform engineering experience across multiple vertical domains that you have within your organization. These vertical domains are typically things like your banking industry or your healthcare industry or automotive industry, or whatever industry that you are in, trying to build the products and deliver them with efficiency and reliability. So what I'm going to be talking about today, number one, going to start talking about the platform engineering as a whole. What does it mean? Or how do I define platform engineering? Then we'll talk a little bit about Gen AI, the advances in Gen AI that we see these days. Then we'll jump right into LLMs and why epochs matter within training your models. Then we'll start talking about applying the RAGs to LLMs in the context of platform engineering. To understand that better, I might take a case study on BFSI, and this is one of the verticals I was just talking about. And then I'll conclude with some discussion around how do you actually get started on this. As you really start talking about this, the first thing to think about platform engineering is the fact that why are you actually doing platform engineering and why do you need to improve that performance more? It's fairly simple, right? So think about it from the point of view of your time to market. Any organization wanting to have faster time to market. So this is where you would need things like your code generation and you're improving your developer productivity and pretty much everything that you need to actually start translating your ideas, your product ideas into products that actually gets deployed to production. As you do that, reducing the cost is also a significant part of how you should do it, right? Because you need to find a way to reduce the kind of repetitive tasks that you have, as well as improve your utilization of your existing resources, whether it is cloud resources, on-prem resources, doesn't matter, any kind of resources you have. As you can start using that less, you're going to reduce the cost. All these things lead into that developer productivity space. This is where you are going to have the reduced cognitive load of your developers, trying to make sure that the developers can actually get their work done faster and they can be more happier. So none of these things have anything to do with Gen AI or LLMs as a whole, right? And so what we are really talking about is that if you were to apply Gen AI to some of these principles, we believe that it can actually yield better results in the end. So having said that, one thing that we should be talking about is what is platform engineering? I don't think we should be really talking about that in 2024, but at the same time, we do have this confusion all the time with respect to what is platform engineering, how does it fit in the larger ecosystem? Let's just spend a few minutes trying to understand how I define platform engineering. There are a few things that you see on the slide. So think of it like 8 or 9 different axes. The first thing to think about is what we always think about from a runtime point of view, your application runtime. If you have a certain type of applications architected in certain ways, maybe you have containers and those containers require orchestration. And generally think of it like your microservices are containerized. As you try and do that, you need to really look at your workload and figure out what's the best way to do it. And that process of translating your application to that runtime of those applications is completely within the scope of platform engineering. The other part of it is a service mesh. This is where you really make sure that your microservices can talk to each other and make sure that there are tools like Istio and all that ensure that there is efficient communication between your microservices and your runtime is managed well. Anytime we talk about platform engineering, the first thing that probably comes to everybody's mind is pipelines. So to those pipelines goes things like compliance and governance that are built in as part of your pipelines. Any organization will have their own set of service catalogs, their own set of services that you really want to actually expose. So those things are, again, part of platform engineering. Observability requires no further explanation. We all understand what that is, but it's not just building the observability platforms and really maintaining that. It's sometimes also about instrumenting and having the observability strategy as to how you're actually going to observe your systems. Any applications require data, and managing that database and the data infrastructure is an integral part of platform engineering. So is the developer experience reporting. So there are a lot of tools these days that actually provide you reports with respect to how your developer experience is improving, what kind of metrics you're tracking, and are these the lagging or the leading metrics, and how do you actually track that? All those things are typically part of platform engineering space. But if you have all these 8 axes, the question really becomes, how do you actually bring it all together? How do you actually make sure that it all works as part of your path to production and as part of your value chain? This is where the internal developer platforms and the orchestrators around it will come in. So these orchestrators make sure that all these different capabilities or these different classes of capabilities work together within the platform ecosystem. So that's how I would define platform engineering. So now let's also take a step back and really talk about, is platform engineering DevOps, and is it SRE, DevX, and all that. Again, these are conversations I still have with a lot of people I talk to. So one of the easiest ways to look at this is that, your platform engineering is the core to all of these terms that we're talking about. If you think of DevOps as a cultural paradigm, a way of doing things that is efficient and making sure that your development process is efficient enough and your developers can actually get the job done in a most efficient manner, platform engineering sort of enables that. And at the same time, your developer experience requires platform engineering. So anything that we talk about in the developer experience, whether it is ensuring that you're reducing the cognitive load of the developers, that requires platform engineering. And it supports the whole SRE framework. So SRE being the site reliability engineering, that really requires some of the platform engineering capabilities. Again, a very simplistic way of looking at it, but this ensures that there is no confusion with respect to what platform engineering is and what the scope of that is. We also can maybe spend a couple of minutes on the actual evolution of this, right? We know that 10, 15 years back, when public clouds weren't as popular as it is today, we used to have data centers and we used to have this idea of DevOps, where we could really try and ensure that your developers were working in as efficient as possible. Over time, we actually started seeing a lot more of those configuration management, large set of servers and scalable issues and things like that. At that point, we started doing a lot more configuration management. And then the DevOps and the early principles of platform engineering started coming out. As we started moving to cloud, where the whole idea of cloud not being a location, being an idea of a way of actually doing your work, a way of working, platform engineering became a lot more prevalent. And that is what has led to the current state, where you typically have a hybrid cloud or at least a multi-cloud situation for any organization. And they are really starting to see, how can you make your platform activities a lot more efficient? This is where both AI-led and AI-infused platforms have become very, very popular. In the larger context of domain-specific ways of looking at platform engineering, when I say domain-specific, going back to my previous point about those banking services or healthcare services or automotive services and those kinds of things, if you look at it, think of it like at the end, this Venn diagram, where one of the circles here is those Dell AI capabilities in platform engineering. So these are any kind of AI capabilities, not particularly a predictive or a generative capability, but it's some kind of AI capabilities. Then you also have certain industry abstraction of those platforms, right? And so for any kind of specific domain platforms, you'll have certain industry-specific data that is available, and you need to abstract that out. And now applying the LLMs for these platforms will also improve that overall experience. But in order for all these things to work together, one of the things that we need to think about is that your organization should be able to support that. So anything that you're doing, the core of the whole success is going to be that culture that you really bring about as part of your organization DNA. And as we just spoke about, so AI hype, even though that's been around for only a couple of years, we all know that we have been using AI in one form or the other for a while. Right? We have predictive AI for a while. We have been using forecasting and trend analysis and incident management, and a lot of those kinds of things. I've been using AI for many years. But with the advent of Gen AI, we are seeing a lot more advances in code generation, test generation, and all that kind of things, which obviously needs LLMs, these large language models, like OpenAI GPT or Codex, which has been really a boon to the whole Gen AI development that we're seeing now. So looking at some of the LLMs that's available today, I'm not going to go through each and every one of them, but as you can see, things like GPT-4 has helped a lot with the code generation and the general assistance of DevOps activities. And Codex has definitely helped things like your IAC and API integration on that. So as you really start looking at what are the kind of models that you need to improve your the platform engineering experience, you would have to first think about what is the problem that you're trying to solve and how can you actually apply some of these very specific LLMs. As you really start training your models, epochs come into play. And the epochs is the whole process of really trying to make sure that you iterate through your training process so that you are converging on the right kind of data, right kind of models, without having a situation where you're really starting to not train them enough or overtrain them. So this is where that convergent process is extremely important. And in order to do that, you need to find the right epochs. Let's look at a very simple example of how something like this could work. So as you really start training your LLMs using epochs, one of the ideas that you need to do is first you start with some kind of model initiation and tokenizing process. Once you set that, you have to really start looking at, can you actually set your hyperparameters? These hyperparameters are things like, what's the number of epochs that you have? What's the size, the batch size that you're training, as well as some of the learning rates and all that. And once you do that, you really go into your data sets and start ensuring that you load your data, make sure that you have the right kind of data that is coming out of the process. Then you actually go in and initialize that optimization process using the model parameters that you set in the previous state, and then set your mode of learning rate. At that point, you can really start going to an iterative process where you really start determining what the epochs are. And for each epoch, really, once you actually go through the training process, make sure that after each batch is trained, see if that level of maturity has the optimization maturity has reached. And once you have reached that, you end up essentially saving that trained model and the tokenizer, make sure that you move on to the point where you have an optimal fit. This is all great, right? I mean, so we looked at the LLMs and looked at how you can train that. Once you do that, one thing that you really have to think about when you talk about, especially when you talk about domain-specific platform engineering, is the application of RAG, so the retrieval augmented generation. So essentially, think of RAG as something that actually bridges your training data gaps. So you train the data in the previous step, and once you have that, you obviously have significant amount of knowledge, but you might still have some gaps if you haven't trained it the level in which you want to train it for the domains. And this allows the LLMs to be a lot more relevant, a lot more accurate, and essentially achieve what you really want to achieve, which is to reduce the cognitive load of the developers, make sure that they are more effective. Again, a very simple way of looking at it. So what on the left side is, if you have an LLM without the RAGs, what you end up doing is that you write the query, you send it to the LLM, and you get the output. But what if you can actually send some domain and organization-specific data? As you send that, what you really find is that you can actually create a lot more data sources, which eventually would turn into an augmented query, a lot more efficient query that will yield better outputs. It's a very simplistic, high-level view of how the RAGs can help. So now let's look at a case study, and specifically on the banking and financial services domain, as to how you could actually enhance your developer experience for this particular domain. Essentially, these engineers are building products within this domain, and you're going to integrate some traditional platform engineering activities together with the RAGs as you do this. So the approach I recommend is going to be like, start with identifying those critical BFSI APIs, and we'll talk what those things are. And then we really start thinking about what are those domain-specific RAGs that you would need. This is the most critical step, right? So you're really going to figure out where you're going to get this data from. Keep all this terminology aside. It's just like you want to build some things, where do you get the data from? Once you do that, the steps 3 to 8, as you can see, are very generic to building any kind of platform activity. Right? Whether it is an engineering platform or business platform, doesn't matter. Those steps should remain the same. And we will actually go through the process to understand how that works. So the first step is identifying your domain-specific APIs. So what are these domain-specific APIs? Fairly simple. Again, if you are in the banking and financial services industry, the kind of things that are important to you are things like your account creation, the balance, account balance, the transactions, and those kinds of things. But as well as things like your payment processing, your loan management, and all that. So you need to clearly identify what those APIs are, what those functions are. If you can't get that right, then anything that you do later isn't going to be useful. So it's very important for you to do some product management, involve your product management teams to make sure that you clearly understand what the business needs are. And even between two different banks engaged in similar activities, your requirements might be different depending on where your business priorities are. Once you do that, the question becomes like, how do you develop domain-specific RAGs? So as you try and do it, there are a few things that you should look at. Think of this like the data sources, right? Your internal documentation, your regulatory guidelines, your ontologies and taxonomies, pretty much anything that where you can actually get this data from would be extremely useful. There are things like, for example, open banking API. So you might want to have your API comply to that within the RAGs. So essentially you include that information as you develop the RAGs. Then you also need to really look at it from the point of view, what are the models available and what are the knowledge graphs so that you can incorporate those things too. So again, this is not an exhaustive list of things. This should be like potentially the kind of things that you might look into, or any kind of data sources that you look into. This might actually turn out to be a good guideline for you to start with. And keep in mind that this is very specific. In this case, it's very specific for the banking, financial services industry. But as you really start looking at healthcare, you can probably find some very similar kind of equivalent RAGs for the things that you see here. Now, once you do that, then the next set of steps are going to be, again, I'm going to use some pseudocode to show this, but it's going to be fairly straightforward from the point of view if you know how platforms are built, right? So think of as like the first step in the process would be to define your APIs for the common tasks. So what are these common tasks in this case? All things that we spoke about in step one. Then once you have that, you essentially create those integration APIs, essentially define those APIs for your ad usage. And then once you define it, go ahead and start exposing those APIs so that these things can be used by your developers. Next step in the process would be to set up a self-serve portal. So in the self-serve portal, again, fairly straightforward idea, go ahead and initialize the portal framework. And this is where we talked about that integration framework that actually brings together your pretty much all the steps within that platform's data ecosystem. And you can go ahead and add the appropriate documentation, and you can see that this is actually pulling in data that you actually collected from various data sources, and then go ahead and add this into your sandbox environment and make sure that you go ahead and deploy that portal. The next step of the process would be to have your ephemeral environments. As a developer, you need to make sure that you have the right kind of environments to continue your development process. So you start by creating your dev containers and then publish those dev containers and provide instructions for the local setup. So this is where you would actually provide that right kind of configurations and the instructions for the developers to execute so that they can actually get this deployed on your local environments. Next one is, again, fairly straightforward. Think about it from your end-to-end observability. As you start setting up your observability, you need to think about your logging, your monitoring, your tracing, the metrics, activities, and all that. And once you have all of those things, expose those tools to the developers so that developers have access to it and can work with it. And at that point, you already set up your pipelines. Your pipelines are things that you would actually set up as part of this step, but then your developers would then go ahead and instantiate it every time they are actually running through a pipeline. So essentially, the things that will happen here is that you just create your pipelines, the ICD pipeline, then add the appropriate stages in there for the security compliance and automated testing and things like that. And your compliance would mostly happen during every step of the pipeline, making sure that you have some kind of compliance at every point that changes are happening. The last step in the process would be to have your security and compliance. So essentially, this is where you're going to be checking about your vulnerability scanning and to know some of the compliance checks that are required by the industry and by your organization, and then ensuring that these are built into the pipeline and report some of these things back to the observability platform or wherever the developers need to report that back to, so that whole ecosystem works together. So as you can see, a lot of these things are very similar. The steps 3 to 8 were exactly similar, irrespective of any kind of domain that you would do this in. And that's the beauty of how you would actually develop this. So having looked at this case study, one of the things that really have to think about is how is this really helping, or how should this be helping? Today, if you really look at a general organization, one of the things, without using significant amount of platform engineering improvements, that about 70% of the time for your developers are in overhead and waste. What it might surprise you, but it's only about 30% of your developers' time is productive. The rest of the time is an overhead, something that is duplicative work, something that they can avoid. But applying some platform engineering principles, what the data shows us is that it can improve significantly. Your value add can increase significantly from 30% to 60%. This is significant, right? But is that enough? Probably not, right? Our goal is to increase that as much as possible. So one of the things that we see is that applying GenAI with RAGs, you can increase that further to at least up to 90%. I haven't seen a lot of data yet. I'm starting to see a lot of very promising data in the space. But if you have some very specific data that shows that improvement, I would love to talk to you and see a lot more about that. You also have to think about, as you really look at this, what's the leverage that GenAI with RAGs is bringing to the table? We know a lot about the coding and debugging and the testing and the monitoring and observability, great areas where that platform's data principles can be applied and improved. But there is also significant leverage that we're seeing within the solution architecture, the requirements analysis, and user research. So you should be really thinking about having that holistic leverage across your overall ecosystem as you go through your path to production, as you really try and make sure that you develop and deliver your product. In conclusion, I just wanted to say that AI is literally changing the way we are doing platform engineering. It's definitely pushing some of the boundaries. But it's been very expensive to train some of these LLMs. So we need to focus on their parts, make sure that we get the right kind of focus there. And ultimately, the difference is going to be with the RAGs, right? Especially when you're doing the domain-specific work, the real benefit is going to be by having the RAGs that taking it to that next step. And one thing never to forget is the fact that why are we doing this? And metrics really tell you why you're doing it, what you want to achieve out of it. Those things doesn't change. So if you really have one eye on the metrics, you should be able to always find that, okay, is this what I'm really trying to achieve, and am I able to achieve that? So with that said, I just wanted to thank you for your time. If you want to connect with me, go ahead and connect me on LinkedIn using that QR code. If you want to learn more about my company, definitely check out that. So thank you so much, and appreciate you listening to this.